سڵاو قوتابیانی عزیز وەرم با دەرسی ڕابردووی تاواکەین هیوادارم ڕازیای خۆت کردبییتەوە ئێستش بە عاقڵی وەرە بە هەندێک پرسیاری بەیەکەوە حەلکەین. Okay? Ready? Let's begin. Question 1. Which of the following is a molecular compound and it can be ionized? First, what's the ionization reaction? Ionization occurs when one of the following classes is dissolved in water. Strong acid, weak base, or weak acid, right? Not strong base. Be careful. Strong base and salts are ionic compounds. Look, NaCl, it's a salt. It dissociates. No. F2, it's not even a compound. This is not a compound. HCl, it's a strong acid. Mister, I don't know. How do you know if it's a strong acid? لبريكة باب لبريكة بتمايسي أي هاور. Okay. D, this is a benzene molecule. Benzene is non-electrolyte. So HCl is the correct answer. 2, a molecular compound can't be ionized. Which of the following is a molecular compound? First of all, this is a salt. It's an ionic compound. This is incorrect. Glucose, yeah, this is correct. It cannot be ionized. Benzene, it's also classified as a non-electrolyte. It cannot ionize. This is also true. The correct answer is D, I mean. Question 3, water attraction is greater than the covalent. Mister, look, last time we have studied this, water attraction as the second point, covalent bond as the first point, and then you said, I remember, if the second point is greater than the first point, such a compound is supposed to ionize in H2O. Look, and now, if water attraction is greater than the attraction force, within the molecule, or the strength of the covalent bond, so this compound must ionize, it must be electrolyte. Okay, it means it must be a strong acid or weak base. Salt, incorrect. Strong acid, correct. Glucose, it's a non-electrolyte, incorrect. The correct answer is B. Water attraction cannot overcome the covalent bond. Point number 1 is greater than point number 2. So we need to have the non-electrolyte. Which of the following is non-electrolyte? Instead of saying which of the following is a non-electrolyte, the question said in which of the following water attraction force cannot overcome the attraction or cannot overcome the covalent bond. The non-electrolyte one is the sugar. It's very easy. Question 5, water attraction is overcome the attraction between the ions. Mister, between the ions. Look, between the ions, it means already we have the ions. It must be an ionic compound. So it's okay if I say which of the following is ionic compound? Yep. Salt, yeah, ionic compound. HCl, it's a strong acid. A molecular compound, no. This is incorrect. So A is the correct answer. This one. Which of the following presents in molecular compounds? Molecular compound as the molecular substances. So the atoms are joined together by a covalent bond. So such a covalent bond can be polar and can be nonpolar. So they contain polar and nonpolar covalent bonds. Water attraction force is greater than the attraction within the molecule. Again, we need to have a molecular electrolyte. Because you know water attraction is greater than the attraction of the covalent bond. Okay? So molecular electrolyte. All the electrolytes. How was the electrolyte? Some of them are molecular, some of them are ionic. So this is incorrect. Because for the ionic, we don't have any molecule. Molecular electrolyte compounds, correct. None of them, no. Molecular non-electrolytes, look at this. None of them must be here, and this one must be here. Okay. You know, this is nothing. It's kind of like, it's like a typo. Okay, so what's the difference between the dissociation and ionization? Last time I've explained this in a very deep detail. the hydronium ion and the hydrated proton. Please, try to have a white page and write what I'm going to explain. Okay? Now I'll give you the most wonderful detail about the hydronium ion and the hydrated protons. Okay? The two terms. So, hopefully you remember how to get the hydronium ion. Once we dissolve the acids or the bases, we will get the hydronium ion. For which case? For the dissolution of the acids, we will get the hydronium ion. But for the dissolution of the bases, we will have the hydroxide ion. Mister. So from now on, should I memorize these points like this? Acids produce hydronium, bases produce hydroxide? Yeah, true? Good. Look, think about this molecule, HCl. It's a strong acid. Good. Previously, the classic way, it was like this. H plus, hey, mister, this is a wrong way to write the, okay, wait, please. Wait, I know what to do, please. Trust me, plus Cl negative. You learn too many things here, okay? This will be your first time to see this technique, okay? Look. This species is called proton, very reactive, can't stay alone. Because of its reactivity, it will attack the other species. It will react, it will be converted into something else. Good. So what to do with its reactivity? As I say, since it's a reactive species, so it will attack something else from its surrounding, because you know, here we have this reaction, in H2O, okay? So then, you know, this particle, this is called a proton. From now on, what's H plus? A proton. What's the name of H plus? Proton. Hydrogen ion, proton. Hydrogen ion, proton. Be careful. H plus is a proton. It has only one proton, nor electron, neither electron nor neutron. Okay, there's only one proton. Look, it will attack water molecule. Okay, to form this. This is water molecule, right? And this proton will attack oxygen atom, and it will produce a bond which is called covalent bond. So now the whole molecule is called hydronium ion, H3O. Good. So that's how H3O is produced. When the proton of the acid attacks water molecule, it will join with the oxygen atom by the covalent bond. So this is called H3O. Good. H3O. This process will be continued further. Still, it's a reactive species. It will attack another water molecule. Now, 2 hydrogens plus 3 will become H5. 1 oxygen plus 1 oxygen, 2. O2 plus. Okay? This process will be continued again. H2O. Look. 5 hydrogens plus 2 hydrogens, H7. 2 oxygens plus 1 oxygen, O3. Okay? H7O3. Plus. So this process will be continued further. Look at this. The following species are called hydrated proton. Okay, because they have been produced in the reaction between a proton and water. So these are hydrated proton, and we only name this one. We need a special name for this, which is a hydronium ion. Okay? And we'll get the following ions in aqueous solution of acids. And the whole process is exothermic. So formation of hydrated proton, it's a special process for this acid's aqueous solution. This is exo-indo process, exothermic process. Okay? So which of the following is the hydrated proton? All of them are hydrated protons. Good? All of them are hydrated protons. Which one is the hydronium ion? H3O is the hydronium ion. In the formation of the following species, the process must be exo or indo exothermic. Okay, so in conclusion, for the dissolution of HCl in water, is there any free proton? No, because since proton, it's a very reactive species, so it will react, it will attack a water molecule, okay, and then the covalent bond must be produced between H and O, okay? So the whole process is called hydrated protons formation. Okay, let's have a quick revision for the whole process. First one, is there any H plus in the aqueous solution of acids? No. Then, how to get the hydrated proton? When we dissolve some acids in water. The process is exo or indo exothermic. How to get the hydronium ion? By transferring a proton of the acid to water molecule by covalent bond. What are the hydrated protons? Are they H3O? I mean, all of them are H3O, or we have something else rather than H3O? Yeah, mister. We have different hydrated protons. So how to identify the hydrated protons? I'll leave this page. How to identify the hydrated protons? Example, this one. If I say H3O is a hydrated proton, H5O2 or H8O3, which of the following is the hydrated proton? Look, there's a very simple technique to identify the hydrated protons. Take the number of oxygen here. How many oxygens do we have? 1. Multiply this by 2, okay? 1 times 2, 2. Then plus 1 equals to 3. We have the same number for the hydrogen. So this is a hydrated proton. It means number of oxygen times 2 plus 1. Okay, this process, for this type of calculation, we should take the same number of the hydrogen's number. Okay, let's do the same thing here. Here we have 2 times 2, 4 plus 1, 5. Do we have 5 hydrogens? Yeah, this is true. This one. Take this number 3 times 2, 6 plus 1, 7. Oh, we have 8 hydrogens. This is now the hydrated proton. That's how you can identify the hydrated proton. Another thing. Look, let me tell you something else. I love this process when I return back the whole steps. Be patient, please. Okay, look at this. So here we have 3 different hydrated protons. Let's count number of the water molecule. This is not a hydrated proton, I'm sorry. So here hydrogen must be 7. Example, if I say H7O3 plus. Look, how many water molecules are included per any of the following hydrated protons? Here we have 1 oxygen, so 1 water molecule is used. 2 oxygens, 2 water molecules are used. Here, 3 oxygens, 3 water molecules are used. Be careful with this. Okay? Let's keep going. Hydronium ion is produced by protonation of water. Protonation, it means transferring a proton from the acid molecule into the water molecule. I have explained the whole processes, but better than this, in a very nice detail. Okay. Formation of, here we have a question. Formation of H3O from the solution of HCl. Will you accept to get H3O for the dissolution of HCl? Wait, mister. You have said that hydronium ion can be obtained by the dissolution of the acid in water. This is the acid, so I will accept this. Accept it, accept it. Not accept it, no. Instead of accept it, it's okay to say favorable. Good. And then the process is exo or indo? It's not indo. It must be exo. The correct answer. Which of the following is the hydrated proton? Look, hydrogen ion, no, it's a proton. Hydronium ion, actually, yeah, it's a type of the hydrated protons. This one, water molecules, water is water. The correct answer is, and hydrogen chloride, no, this is a molecule of acid. So the correct answer is B. But if I say which of the following is a proton, then A is the correct answer. I'll leave this for you. I have explained it. This question also. Okay? Another point. Here we have a notes box. Stay with me. I'll show you a very nice sequence. Try to have it here or in someone else if you don't have my booklet. Look. Hydronium ion concentration is directly proportional with the strength of the acid. It means as much as the acid gets stronger, it will produce more hydronium ion concentration. Let me show you how. Okay? Look. Assume that HX can be any acid. Okay? This bond is called covalent bond. Covalent bond. Okay. Let's have the following steps. First point. If the covalent bond gets more polar, so if polarity is increased, as the polarity increased, second point, the bond gets weaker. The bond will become weaker. Weaker. So if it's weaker, then it needs more energy to be broken or less energy? Less energy, because we have something very weak, can be broken easily. So less energy is needed. Good. Fourth point, once the bond gets weaker, it will ionize more or less. Don't you remember the attraction within the molecule or covalent bond? How is the relation between the attraction within the molecule covalent bond with the ionization? Okay, are they direct or inverse? It means the ionization and the covalent bond strength. Are they direct or inverse? They were inverse if you remember the first point. So as the bond gets weaker, the compound ionizes more. So more ionization. Okay, once the compound ionizes more, lastly we will get more H3O. So look at this, mister. The strength of the bond with the strength of the acid, you know, they are inversely proportional. So the acid is stronger. So look at this. If the acid is stronger, the bond must be more polar, less energy will be needed, the bond is weaker, the ionization increase, the hydronium ion increase. Look, the following things are directly proportional. The strength of the acid, the ionization, the concentration of hydronium ion. So as the acid gets stronger, the degree of ionization increased, the concentration of hydronium ion is increased. بينسو point أنا بابي من زانا strength, ionization of the acid, of course. Hydronium ion concentration. The following big brackets, parentheses, are stand for the molar concentration. These are directly proportional and they are inversely proportional with, of course, polarity also here. Okay? And they are inversely proportional with the bond strength and amount of energy. Amount of energy needed to break the bond. Okay? The following two things are direct. The following four things are direct, and these are inversely proportional. This is something really important. It means, Mister, if the polarity is increased, the strength of the acid is increased, the ionization is increased, H3O is increased. But the bond gets weaker, I mean the bond strength, okay? Aga polarity increase be, bond strength gets weaker, okay? And the amount of energy must be less. Be careful. But if the strength of the bond gets greater, then the polarity must be decreased. I mean, you know, the following points are inversely proportional with each other. Be careful. The stronger bond, it means we have less polar bond. Good. So now, we have a question here. Dissolving, this one. Which of the following has the maximum hydronium ion concentration? Hydronium ion concentration maximum, it means the more strong acid, the strongest acid. So which of the following is the stronger acid? HCl, it's a strong acid. HF, weak. No, this is a weak acid. Okay, this is a base. We don't need this. So this is the correct answer. Now let's compare the electrolytes. Okay? The electrolytes are classified into weak and strong electrolytes. The term of weak and strong electrolytes are related to the electricity conductance strength. Okay, strong electrolytes, for the dissolution of the strong electrolytes, we will get an aqueous solution that conducts electricity stronger. Look, electrolytes is any electrolyte, strong electrolyte is any compound whose dilute aqueous solution conducts electricity well. This is due to the presence of all or almost all the dissolved compound in the form of ions. It means if we dissolve a strong electrolyte in water, all the amount of the dissolved substance, or almost all of them, will be converted into the form of ions. Example, strong bases, strong acids, and soluble salts. These are strong electrolytes. But for the weak electrolytes, okay, weak electrolyte is any compound whose dilute aqueous solution conducts electricity poorly. It means we will get less ion because a small amount of the dissolved substance must be converted into the form of ions. Okay? So let me differentiate between them like this. Look, if we have a strong electrolyte, okay, to form the ions, and weak electrolyte to form the ions. For the strong electrolyte, all the amount of the dissolved substance must be converted into the form of ions. So we'll get more concentration of the ions. Here we have less concentration ions. Less concentration of the substance. So the compound itself will become disappeared. There will be no left amount of the strong electrolyte itself. All the amount, the primarily thing here will become for the ions. Okay, there will be no compound here. But for the weak electrolytes, only a small amount of this will be converted into the form of ions. So here we have less ion, but here we have more concentration. Look, inside of the aqueous solution of the strong electrolytes, we only have the ions. But for the weak electrolytes, we have the weak electrolyte itself with the maximum concentration with a trace amount of the ions. Be careful with this. Look, again, I'll repeat to you. Strong electrolytes, all of them will be converted into the form of ions. So inside of the aqueous solution of the strong electrolytes, we get more amount of the ions and no amount of the strong electrolyte. But for the weak electrolytes, we will have both of them. The majority will be for the compound itself, and here we'll get the trace amount. That's why this aqueous solution conducts electricity strongly, but this one conducts weakly, poorly. Okay? I have explained the following points. The following points. Look, Nitrous acid, HNO2, it's a weak electrolyte. Okay, so let's have the reaction for nitrous acid. HNO2. It's an acid, so it will ionize. We have to use the reversible arrow to establish the equilibrium. Okay, since it's an acid, so we'll transfer proton here to water molecule to form the hydronium ion plus NO2. Negative. Good. How about the nitric acid? Nitric acid is a strong acid, strong electrolyte. So I'll try the ionization reaction for the nitric acid. Plus H2O, direct arrow to form H3O plus NO3. Look, in which case we'll get, or which one produces more hydronium, the stronger one. Here, there will be no left amount of HNO3. All the amount of HNO3 must be converted into the form of ions. So we have only cation and anion in this aqueous solution. But here, we will have the electrolyte itself, cation and anion. Here, less concentration, and maximum concentration will become for the electrolyte itself. Look, mister, that means if we dissolve strong electrolyte, the strong electrolyte will disappear. We'll have only the cation and the anion, more concentration. But if the electrolyte is weak, then we will have the electrolyte itself with the maximum concentration with the small amount of ions. Okay? Good. Distinguish between the terms of strong, weak, diluted, concentrated. Look. First, strong and weak. Strong, weak. Okay. Strong, it stands for more ionizable or more dissociable. More ionization or more dissociation, no problem. Dissociation or dissociable, okay? But weak, less ionization or dissociation. So the terms of strong and weak are related to the degree of ionization and dissociation. As the degree of ionization and dissociation gets greater, the compound must be strong electrolyte. But if they ionize or dissociate less, the compound must be weak electrolyte. How about the diluted and concentrated? Look, diluted and concentrated, they're related to the amount of solute. Diluted, it means less amount of solute, but concentrated, more amount of solute that is dissolved. Are they related to each other? The following four different terms. Look, are they related to each other? No, there's no relation between them, because if I say this one, look, 10 molar HCl. HCl, it's a strong electrolyte, and the number is great. So this is strong. Diluted and concentrated, they related to the number with the molarity or molarity. If the number is big, it's a concentrated. If the number is small, it's a diluted. So this is concentrated. Concentrated and strong. But this one, 10 molar HF. Look, this is a weak electrolyte and concentrated. So this is a concentrated and weak. This one concentrated and strong. Or 0.00000001 molar HCl, I mean, this is strong and diluted. But if I say 0.000001 molar HF, okay, this is weak and diluted. So there's no relation between them. Look at here. This is a very nice point about HX. HX. X stands for the halogens or halogens. No problem. Halogens could be HI, HCl, HBr, HI. For them, it's possible to have them in their gaseous state. In this case, we will say hydrogen, halide or hydrogen halide, or in their aqueous form, which is called acid. Okay, I'll correct the naming system here. Look, hydrogen halides, it means hydrogen plus halogens. Hi, HCl, HBr, HF. If they are in the gas state, we will say hydrogen iodide, hydrogen chloride, hydrogen bromide, hydrogen fluoride. First, they are gases, so they do not conduct electricity because they must be dissolved in water to release their ions, then they can conduct electricity. However, they are electrolytes, but they cannot conduct electricity because they are gases. Then, they are molecules, yeah, because still they are gases, okay? After their dissolution, then they stay in the form of their ions. They are highly soluble in water. It means all of them are highly soluble. All of them are highly soluble. Be careful. I didn't say which one is strong or weak. All of them are highly soluble. How about this? In their aqueous state, we will say the acids. So the name will be hydro plus root of name plus the term of IC, then plus acid. Okay, look. HI, hydro, root of the name, iodic acid. Look, HCl, hydrochloric acid, hydrobromic acid, hydrofluoric acid. They conduct electricity because they have been dissolved in water. Okay, Hi, HCl, HBr, they are strong acids. This one is a weak acid because they completely ionize, but this one partially ionized. Later, I'll give you more detail about the completely partially ionization. Weak acids, they ionize partially, but strong acids, they ionize completely. This is a very, very, very important point. Mister. So if I say, which of the following is a highly soluble but weak? HF. Which of the following is a highly soluble but strong? HBr, HCl, HI. Which of the following is a highly soluble substance? All of them. Okay? Be careful. So what's the difference between the hydrochloric acid and hydrogen chloride? Okay, hydrogen chloride and hydrochloric acid, they both are HCl, but hydrogen chloride is a gaseous substance, but hydrochloric acid, it has been dissolved in water. Good. Look, explain why HCl, HI, HBr are strong electrolytes and HF is a weak electrolyte. Because they ionize completely, they produce more H3O, but this one ionize partially to release less H3O. Good? Nice? Okay. For each of the following pairs, tell which solution contains larger total concentration of ions. Stay with me. Let me tell you something. Once you see concentration of ions, look, the term of the concentration of ions contains two parts. Okay? I need a white space. Concentration of ions. It means we have concentration which is molality or molarity with the number of produced ions. Good. So what's the concentration of the ions, or ionic concentration also called, equals to the concentration times number of ions that can be produced. This rule is used for the soluble salts, strong acids, strong bases. Not for the weaks. Be careful. Okay, what's the ionic concentration or concentration of the ions? Concentration times number of the ions that can be produced. This is for the soluble salts, strong acids, and strong bases. Not for the weaks. please. Okay, which of the following releases the maximum concentration of the ions? Here, the concentration is 0.1. How many ions can be produced per this? H3O and Cl. We have 2 ions. 0.2. This is the answer for this. How about this? 0.05 again times 2 equals to 0.1. So this is the correct answer among between the following 2 substances. Here, look, 0.1 times 2 equals to 0.2. How about this? Okay, Mr. H and F, 0.1 times. No, this is a weak electrolyte. In terms of the ions, directly remove it. Even if the concentration is 100 times greater than this, we don't take the weak electrolyte. We don't compare weak electrolyte with the strong electrolyte. In terms of the concentration of the ions, be careful. Agar strong و weak man هبو هرگز weak compare مکه با strong اگر باسی ionic بسیارکه. In terms of the concentration of the ions, you don't have to compare the weak electrolytes with the strong electrolytes, even if they have a greater concentration 1,000 times. Okay? So directly cancel this. In terms of the ions, be careful. How about this? 0.1 times 2 equals to 0.2 here. 0.1 times how many ions? 2 Cl negative with 1 calcium plus 2 times 3. So the result is 0.3. Okay? So which one is the greater result? This one. Sir, what if we have H2SO4? Okay, the concentration of H2SO4 must be multiplied by 3 because we will get 2H3O with SO4, 3 ions. 3 ions. Okay? Good? Let's solve the following questions. Which of the following exists mostly in ionic rather than molecular form? It means we have more ion. So it must be a strong electrolyte. Because it's a molecule, so it must be a strong acid. So which of the following is a strong acid? HCl? Yep. HF? No. H2SO4, it's a strong acid. The correct answer. Which of the following exists mostly in molecular rather than mostly in molecular? It means weak electrolyte. Mr. How about the non-electrolyte? Because the question says rather than ionic. It means there are some ions, but by small amount. That's why it's an electrolyte, but weak electrolyte. So which of the following is a weak acid? For this question, weak base also is true. NH3 also will become true. Okay? Which of the following is a highly soluble but ionizes slightly? Highly soluble but ionizes slightly. First of all, it's better if I say which of the following gases. Which of the following gases? Okay? Once you see this, it means already they are in their gaseous state. Which of the following gases is a highly soluble but ionizes slightly? First, all of them are highly soluble, but this one ionizes slightly because it's a weak acid, will become a weak acid, of course. But these are ionized completely. Which of the following is a highly soluble and ionizes more? Of course, C and A, since they produce a strong acid solutions, okay? The strong acid solutions, I mean. So they ionize completely. This one ionizes partially. Look at it. A solution of 15 molar acidic acid is, 15, the number is great. This is a concentrated acidic acid, weak. It's a weak acid. So concentrated and weak. Concentrated and strong, no. Concentrated and weak, correct. It's not a diluted because the number is good. Okay, how do we know if the number is great, if the number is big or small? Okay, once you see something like a decimal number 0.001, 0.002, these are small numbers. But if we have 5 molar, 10 molar, 15 molar, you know, in chemistry, these are very big numbers for the concentration. The last question. Yeah. And then in the next lesson, I'll start to explain section 2. Be careful, my dears. دەزانم زۆر بەهێواشی شەڕح دەکەم. بەجددی وەکو پێم گوتی ئەمن ئێستا مامۆستای تایبەتی تو مەوادابنێ لەسەر مەلزەمەیە من لەگەر ڤیدیۆیەکانم بە جوانی بخوینە عاقڵ. وادانێ مامۆستای تایبەتی توما لێ بەهێواشی دەڕۆم. وردە لەگەڵت خێرا دەبم. لە section 2, I will speed up a little bit. Then I will speed up. Then, you know, continuously, stepwise, stay with me. Okay? Just be patient. Which of the following has the maximum ionic concentration? Ionic concentration, mister. You have said once you see ionic concentration, remove all the weak electrolytes. We don't need this. Okay. How about these are soluble salts? They have been classified as a strong electrolytes. So here, 0.1 must be multiplied by 2 equals to 0.2. I'm sorry, please. This one must be multiplied by 2. 0.4 times 2 equals to 0.8. Here, 0.3 times 3 equals to 0.9. This is the greatest ionic concentration among the following answers. But now, I will play with this question. What about if I say, which of the following has the maximum concentration? I'll remove the term of ion. In this case, we only need the numbers. We don't need if the compound is strong or weak. Just take the numbers. The greatest number, the more concentrated. Just now I have explained before 2 minutes. Okay? So in this case, if I say which of the following has the maximum concentration, just say A. Okay? So alhamdulillah, as section 1 man تواو کرد. لەگەڵم بە چاوەڕێکە لە section 2 ئینشاءالله دەبینەوە. تاو کات خوا دەر ئاهلە بیرت بی. جوان بخوینەوە ئاگادار بە. Please. Okay? Try to review the whole things that I told you. Just be happy, stay safe. Everything is possible for you. I mean, it's okay for you to get the highest mark in the future, to become a doctor, anything, please. Just believe yourself. That's all, okay? See you in the next lesson.